I'm Anil Kumar, and in this particular video, we will learn techniques of solving inequalities. We'll actually find the answer by estimating from the graph itself. So we are given graph of f of x, which is x squared minus 1, and g of x, which is x sine x. So x squared minus 1 is a parabola, so that is f of x for us, and g of x is the sine wave. We need to solve for g of x is greater than f of x. So the sine wave we know is greater than f of x in this interval. Right, so that is the interval. So basically we need to find what these points are. So that is our solution. From the symmetry we can say if I find the point A here, then I know it is between plus and minus A. Right? So that is what our strategy is. What we should do is we should actually calculate the values for these two functions taking different x values, and then we can approximate our answer, correct? So in this case what we are going to do is we will write what f of x is and what g of x is for different values of x, and we'll just compare our answers. Let us estimate first. It seems to be midway between 1 and 2. So I'm thinking this is kind of a very rough sketch, right? So 1.5 is the value which I will start with. So we can start with x as 1.5 and find what f of x is and what g of x is, right? So f of x will be 1.5 square minus 1, and that is equals to 5 over 4. Let's write in decimals. So it is 1.25. G of x is x times sine x. Your calculator should be in radians for this, right? So first step is convert your calculator to radians and then calculate your answer. So for 1.5 we get 1.49 for g of x. Now if you observe, we got g of x higher. That means we are on the left side, right? Because after this point parabola is higher, so we should move to the right. Is it okay? So let's try the value 1.6 now. So 1.6 square is equal minus 1, let's do, is equals to, in decimals, 1.56. 1.56. Now let's do 1.6 times sine of 1.6 within brackets. Remember, it should be in radians. 1.599, right? So we get 1.599. So still sine function is higher, so we can move slightly more to the right. It's very close, 1.56. So let's try 1.61. Okay, so if I do 1.61 square minus 1, what do I get? I get 1.5921. On the other hand, 1.61 times sine of 1.61 results into 1.60. 1.608. So we are still very, very close, and what we see is still that sine function is higher, right? So we can move still right, left, right? So let's try the value of 1.62. So 1.62 square minus 1 is equal to 1.624, and 1.62 times sine of 1.62 within brackets is equals to 1.618. Now the things have changed. That means the point of intersection is somewhere in between, correct? So we can now try a value which is like 1.615, for example, right? So let's try this. 1.615 square minus 1 equals to 1.608. And for g of x, 1.615 times sine of 1.615 bracket close equals to 1.613, right? So we are getting close to it. So we can see from here that the values are converging. Sine is still greater, so we could go slightly more to the right, correct? So that is how you can actually estimate your values, correct? So 1.615 could be 1.616 or 7, may give us even closer value, right? So let's try one more value, which is 1.616, for example. Okay, so this is the last value, 1.6 1.16, right? So we'll estimate from here itself. We are actually close. Is 1.611. For the sine function, 1.616 times sine of 1.616 bracket close equals to 1.614. Do you see? So we have got same answer to two decimal places. So that's a good value to go with, right? So we can say that this point A is 1.614, and on the other side it should be minus 1.614, correct? And therefore we can say g of x is greater than f of x, is greater than f of x. G of x is a sinusoidal function in the interval when x is between 1.616, 9 minus and 1.616. So it is between these two values approximately, right? So that is how, see, it is still greater, right? So that is fairly good approximation for our answer, right? So that is how you could estimate and then come closer and closer to your solution to make it more accurate. So the steps involved here is first to estimate and then build up accuracy by coming closer and closer to the value and then just calculate, right? So that is best you can do with the help of a calculator. I hope that helps, and this is a very powerful technique normally used by the calculators, but we can also use it and get our answer. Thank you and all the best.